Okay, welcome dear my followers. Let's start today's topic. We start from this exercise 1.24. A job applicant finds that a firm A offers a starting salary of 31,100 with a guaranteed raise of 1,200 per year, whereas firm B offers a higher starting salary of 35,100 but will guarantee a yearly raise of only 900. So let's identify the given things here from firm A. We have given 31,100. This is A1. We have for firm A. Okay, let's firm A. We have given A1 which is equal to 31,100 and common difference dt which is equal to 1,200. 1,200. Firm B. We have starting value A1 which is equal to 35,100. 35,100 and common difference D which is equal to 900. Now what we need to find here? Let's go to question number A. Number 1A. Question number 1A. The question says, what would the annual salary be in the 11th year at firm A? What we need to find here? A11. Here is the answer. A11 which is equal to A1 plus 11 minus 1 times common difference D. 11 minus 1, 10. Let's write it like this. 11 minus 1 times D which is equal to A1, here we have 31,100 plus 11 minus 1, 10 times common difference D 1,200 which is equal to 31,100 plus, after multiplying this we get 12,000. This is equal to, let's add this, 31,100 plus 12,000 which is equal to 43,100. This is the solution for question number A. Let's go to question number 1A. B. Number 1B. What we want to find here? What would the annual salary be in the 11th year at firm B? A11. We want to find here also A11. A11 which is equal to A1 plus n minus 1 times 11 minus 1 times common difference D which is equal to A1 which is equal to 35,100 plus 11 minus 1, 10 times common difference D 900 which is equal to 35,100 plus 9,000 which is equal to, let's add this, 35,100 plus 9,000 which is equal to 44,100. This is the solution for question number B. Let's go to question number C. Number 1, C. What you want to find here? Over the first 11 years, how much would be earned at firm A? We want to find here S11. Let's compute it. S11 here. S11 which is equal to 11 divided by 2 times A1 plus A11 plus A11. This is equal to, let's 11 divided by 2 into, we have A1 in the firm A 31,100 plus A11, this here we have 43,100 which is equal to 11 divided by 2 into, let's solve this, 31,100 plus 43,100. This is equal to 74,200, which is equal to 74,200 times 11 divided by 2. This is equal to 408,100. 408,100. This is the solution for question number C. Let's go to question number D. Number 1, D. What we want to find here? Over the first years, how much would be earned at firm B? We wanted to find here also S11 in the firm B. S11 which is equal to, S11 is equal to 11 divided by 2. Product is A1 plus A11 in the firm B. A11 which is equal to 11 divided by 2 in bracket. A1, we have A1 35,100 plus A11, we have A11 44,100 is equal to 11 divided by 2. Product is, let's add these two, 35,100 plus 44,100 which is equal to the sum of these two will be 79,200. This is equal to, now let's multiply this, 79,200 times 11 divided by 2, which is equal to, it's 435,600. This is for firm B. S11, the sum of terms starting from 1 up to A11 will be 435,600. Let's go to question number 1, E. Number 1, E. What you want to find here? Compare the amount earned in 11 years in firms A and B. Let's compare. We have S11 and in firm A and in firm B. So let's subtract from this one to compare the total values in firm B and firm A. So S11 in firm B minus S11 in firm A, sorry, which is equal to 435,600 minus 408,100, which is equal to, let's subtract from this one, we have 435,600 minus 408,100, which is equal to 27,500. This is the difference in film B and film A. Now let's go to the next question, question number 2. Question number 2 says, a contest offers a total of 18 prizes. The first prize is worth $10,000 and each consecutive prize is worth $500 less than the next higher prize. Find the value of the 18th prize and the total value of the prizes. So here we have given things. This is the initial value A1 and the common difference will be price is worth $500 less the next higher price. So common difference it will be minus 500. So let's do here. Question number 2, we have given A1 which is equal to 10,000 and common difference D which is equal to minus 500. Now what we need to find here? We want to find the value of the 18th price, A18. Let's compute it. A18 which is equal to A1 plus 18 minus 1 times common difference D, 18 minus 1 product with common difference D. This is equal to A1 plus 17 times D. Now here A18 which is equal to A1 will be 10,000 plus 17 times minus 500 which is equal to 10,000 minus 17 times, let's multiply 17 times minus 500 minus 80,500 which is equal to, let's subtract again, 10,000 minus 8,500 which is equal to 1,500. Now let's complete the other question here. Find the value of the 18th price and the total value of the prices. We want to find here also S18. Let's compute it. S18 which is equal to 18 divided by 2 product with A1 plus A18. This is equal to 18 divided by 2, 9 times. We have given A1 10,000 plus what about A18, 1,500. So this is equal to, let's add these two, 9 times the sum of this 11,500 which is equal to, let's multiply this 11,500 times 9 which is equal to 103,500. 103,500. This is S18. Now let's go to the next question. Question number 3. A contest offers 10 prizes with a total value per 13,250. If the difference in value between consecutive prices is per 250, what is the total? What is the value of the first prize? What you need to find here is A1, first prize, A1. This is S10. What about this? This is the common difference. If the difference in value between consecutive prices is per 250. So our common difference will be minus 250. So here is the given thing is here is 10. First is 10, which is equal to how much is 10? 13,250. 13,250. Again, common difference which is equal to minus 250. The other thing, this given thing, what you need to find here, A1, the first term will be how much. So let's substitute the formula here. Is 10, which is equal to 10 divided by 2. Product is A1 plus A10. This is equal to 10 divided by 2, 5 into. What about A1? We don't know A1. A1 plus again A10. A10 can be calculated using this formula, A1 plus 10 minus 1 times D. 10 minus 1 product is D. This is equal to 5 product is A1 plus A1 2 times of A1 plus here 10 minus 1 9 times D. 9D, that is 9D. This is equal to 5 times 2 times of A1. We don't know A1. Let's put it as it is to A1 plus 9 times D. D will be here 9 times 9 star into minus 250. So let's complete this again. This is equal to 5 product is twice of A1 minus 250 times 9 product is 250 is equal to 2250. S10 we have given here, so let's substitute S10, which is equal to 13,250, which is equal to this. Now let's divide both sides by 5. Let's distribute this. Okay, no problem. 13,250, which is equal to 5 times 2 10 A1 minus 5 times this 2,250 times 5, which is equal to 11,250. Now let's take these two left sides. 30,250 plus 11,250, which is equal to 10 times A1. 10 A1. Now let's subtract this 11,250. Let's add this to 30,250 plus 11,250, which is equal to 24,500. 24,500, which is equal to 10 times A1. 10 A1. Now let's divide both sides by A1 by 10. A1, which is equal to 2,450. 2,450. This is A1 value. This is 24,500. This is the solution for question number 3. Question number 3. What is the value of the first price? The first price will be 2,450. This is the answer. Okay, let's go to the next topic. Here is the next topic. Example 1. A flower 110 cm high is planted in a garden. At the end of the first year, the flower is 120 cm tall. Thereafter, the growth of the flower each year is half of its growth. Half of its growth here in the previous year. Show that the height of the flower will never exceed 130 cm. Draw a graph of the relationship between time and growth. So here is A flower 110 cm high is planted in a garden. At the end of the first year, the flower is 120. How much increase here we have? 120 minus 110, 10. So in the first year, the flower is increased by 10. In the next year, the half of it grows. So the first increment will be here is the first increment 10 here we have 10. The next increment 10 divided by 5. Next by half 5 over 2. Next again 5 over 2 over 2 5 over 4 and so on. Now shows that the height of the floor will never exceed 130 cm. This is obviously a geometric sequence with the first term 10 and a common ratio r 1 over 2. Now let's compute the sum of this geometric sequence. Let's compute s infinity s infinity which is equal to g1 the first term, g1 again r. The common ratio r will be 1 over 2. 1 over 2 is strictly less than, so we use the formula g1 over 1 minus r. We use this formula 1 minus r. So this can be calculated. We have g1 10 over 1 minus r, 1 minus 1 over 2. This is equal to 1 minus 1 over 2 is 1 over 2, 10 over 1 over 2, which is equal to 20. Now this is the increment, the total increment. A flower 110 cm high is planted in a garden. So what we will add here? 110 plus 20, 110 cm plus 20, which is equal to 130 cm. So the height of the flower will never exceed 130 cm. Draw a graph of the relationship between time and growth. So to sketch this graph with xy plane, that means in x-axis we use time, and for y-axis we use growth. So it is. Let's check the graph. The graph looks like this. Again, therefore the growth of the shrub is limited to 20 cm, and the maximum height of the shrub is therefore 110 cm plus 20 cm, 130 cm. This is the total length, the total height of the shrub. Let's go to example 2. Given a square with side A, the side of the second square is half of its diagonal. The side of the third square is half of the diagonal of the second square, and so on, as shown in the figure below. Find the sum of the areas of all these squares. Okay, let's do this. Given a square with side A. So with side A here, like let's read this, or simply can't draw easily here, so easily read it. This one you can read from this. Generally to compute the area of the square, we use the area of the square. Area for a square can be computed area which is equal to length square, L square. This is the formula to find the area of the square. We have side length A, so which is equal to A square. A square will be the area of the square. The side of the second square is half of its length, half of its diagonal. So we have to compute the diagonal also. To compute the diagonal, use the Pythagoras theorem first. In this diagram, let's see here. From this up to this, we have A. Again, this is A, this is A, this is A. So how can you compute this diagonal? Use Pythagoras theorem. Here we have right angle A square plus A square, which is equal to this diagonal square. Using the same fashion, we can compute the area of this all. So the last solution will be 2 times of a square. Let's go to exercise 1.25. This exercise 1.25. Suppose a ball is dropped from a height of h meter and always rebounds to r of the height from which it falls. Show that the total vertical distance that could be covered by the ball is h times r plus 1 over 1 minus r meter. Assume that the ball will never stop bouncing. So from this here, suppose a ball is dropped from a height of h. So you have the height h. So to compute this with geometric series formula, let's compute it here. So we use h plus rebounds means 2 times of h, twice of hr plus twice of hr square, twice of hr squared here, plus again twice of hr cubed, twice of h r power 3 plus twice of h r power 4. Small letter r, let's put it like this, plus and so on. Plus and so on. Now let's compact this. Let's take common h here. That is equal to h into 1 plus 2r plus 2r square, 2r squared plus 2r cubed plus 2r is a power 4, 2r power 4 plus and so on. This is equal to h times. Now this is geometric series 1 plus 2r. Okay, let's put it here, 1 plus. From this up to this, we can take common 2r into 1 plus 1 plus r plus r square plus r power 3 plus and so on. Now from this we have h into 1 plus, this is the 2r times 2r into, this is the first time. What is the common ratio? R really. Common ratio r is r, so we use 1 over 1 minus r. So here is 1 over 1 minus r. Sorry, 1 over 1 minus bracket 1 minus r. Sorry. Let's edit it here. 2r 1 over 1 minus. This is unnecessary here. This bracket is here, this one, okay, this one is unnecessary bracket. So 2r into 1 over 1 minus r. 1 minus r. So let's simplify this. This is equal to h times 1 plus 2r times 1, 2r, bracket 2r over 1 minus r. This is equal to, now let's take here, let's go take common denominator 1 minus r, h into 1 times 1 minus r, 1 minus r here, plus 2r over here 1 minus r. this is equal to, now let's compute this, h into 1 minus r plus 2r. Minus r plus 2r is r, so 1 plus r. 1 plus r over 1 minus r. Let's put it in bracket like this. This one. You have bracket like this. So this is okay, this can be expressed like this, h into, let's rearrange the place of 1 and r plus 1 over 1 minus r. This is the total vertical distance that could be covered by the ball is h into r plus 1 over 1 minus r. Let's go to the next question. Example, question number 2. Given an equilateral triangle with the side A, its side is the side of another equilateral triangle. The height of this triangle is then the side of the third equilateral triangle, and so on. Here we have given an equilateral triangle with the side A. Its side is the side of another equilateral triangle. So this is the same, somewhat similar with this question. So to do this, we need graphical explanation. So we can express this in this figuratively. So do it this by your own. Now let's go to summary part. Sequence an is a function. Sequence by itself, it is a function whose domain is positive. The set of positive integer or a subset of consecutive integers that starting from 1. A sequence A1, A2, A3 and so on is denoted by like this. You can express like this. Again, a sequence that has a last term is called infinite sequence. Finite and infinite. Otherwise it is called infinite. A recursion formula is a formula that relates the general term of a sequence to one or more of the terms that come before it. Arithmetic and geometric progression. An arithmetic sequence is one in which the difference between consecutive terms is constant. Arithmetic sequence we have common difference d, whereas geometric progression we have common ratio. If n is an arithmetic progression with the first term a1 and the common difference d. An arithmetic progression, okay. an can be computed using this formula a1 plus n minus 1 times d. This d is common difference a1, the first term, n represents what the term, number of terms. Whereas a geometric progression is one in which the ratio between consecutive terms is a constant, and this constant is called common ratio. If Gn is a geometric progression with the first term Gn and the common ratio r, then the nth term is given by Gn is equal to 1 times r to the power of n minus 1. This is the nth term formula for geometric sequence. Partial sum. The sum of the first n terms of the sequence, n that n starts from 1 up to infinity, denoted by Sn, is called partial sum of the sequence. The sum Sn of the first n terms of an arithmetic sequence with first term a1 and common difference d is, we can express like this. Sn is equal to summation k starts from 1 up to n ak n over 2 twice of a1 plus n minus 1 times d, or Sn is equal to k starts from 1 up to n ak n over 2 product with a1 plus an. That means an, here we have an a1 plus n minus 1 d. So we can split this twice of a1 as a1 plus a1. So a1 plus n minus 1 d can be replaced by an. So this is the partial sum formula. We can use either this or this one. In a geometric sequence, Gn that n starts from 1 up to infinity with common ratio r, the sum of the first n terms Sn is given by Sn is equal to n times J1 if r is equal to 1. Common ratio r, if common ratio r is 1, Sn will be n times the first term, whereas if r is different from 1, Sn will be like this, J1 times 1 minus r the power of n over 1 minus r. Convergent series and divergent series. In a sequence, if n that n starts from 1 up to infinity, Sn is the n's partial sum, such that as n tends to infinity or approaches to infinity, Sn approaches to small letter s, where s is a finite real number. To say a sequence is convergent if the n's partial sum as n approaches to infinity, Sn approaches to s, where s is finite real number, we say it's an infinite series, summation that n starts from 1 up to infinity and converges to s. Otherwise the series diverges. Now let's do this particular summary exercise, review exercise. List the first terms of each of the sequence whose general terms are given below, where n is a positive integer. Number a, n is equal to n power n over n factorial. Let's list out here some terms. Here is when n is equal to 1, n is the power of 1 is 1, 1 over 1 factorial is 1, so the first term will be 1 comma. When n is equal to 2, to the power of 2, 4, 4 over 2 factorial is 2, 4 divided by 2, 2. The second term will be 2. The third term, 3 the power of 3, 27. 27 over 3 factorial is 6, so 27 over 6. 27 over 6, let's simplify. Okay, let's put it 27 over 6, which is equal to, this can be simplified. Now my terms to be wanted to list here 5 terms. So let's simplify this. 27, 3 is the power of 3, 27, yes, 3 factorial is 6. Now let's simplify this and this by 3. 27 divided by 3, 9. 6 divided by 3, 2. 9 over 2. Comma here. And let's take let's compute the fourth term. For the power of 4, 64 over 4 the power of 4, not 64. For the power of 4, how much? Let's compute it here. For the power of 4. Let's use this calculator. For the power of 4, $256. So it is 256 over 4 factorial is 24. Let's simplify this. 256 divided by 256 divided by 24 is equal to okay, now you go see. Okay, let's 256 divided by 8. Let's simplify by 8. This is equal to 32, so we can put it here. 32 over by 8, 4. So by 8, 3. After this we can't simplify, so we put it like this as it is. Now let's go to the next term. Here first, second, third, fourth, fifth, last term, fifth term. 5 the power of 5. Let's compute it. 5 the power of 5 is equal to 3125. 3125 over 5 factorial 120. 3125. Now let's simplify this. Let's simplify this by 5. 3125. 3125 divided by 5, which is equal to 625. 625 divided by 120 divided by 5. 120 divided by 5 which is equal to 24. Again, let's simplify this by if it can't be simplified, let's simplify 625 by 3, which is equal to can't simplify. Okay, let's try one more by, so we put it here, we can't simplify after this. So these all are 5 terms for this sequence. Let's go to question number B. For question number B, let's start for in 1. When we substitute 1, minus 1 the power of 1 is minus 1. Minus 1 the power of minus 1 here again, sine n times 1 times pi, sine pi will be 0. So here this is 0, automatic 0. So here we have minus 1. The first term will be minus 1, comma. The second term, this is positive. Minus 1 square is positive 1. This is positive 1, sine 2 pi. This is 0. So minus 1, positive 1. The next term, positive 1, comma. The third term is 2 minus 3 pi. Okay, where is 3 pi? Sine 3 pi. Let's calculate it. Sine 3 pi. Sine 3 pi. Let's calculate it here. Sine 3 pi. Where is sine trigonometric? Sine 3 times pi, sine 3 pi. So sine 3 pi, here we have 0. So 0 times minus 1 is 0. So minus 1 the power of 3, minus 1. The next term, minus 1 here. The 1, 2, 3. The fourth term, this is positive. 4 pi, also 0. So positive 1. The fourth term, positive 1. 1, 2, 3, 4. The fifth term, sine, again this is 0, minus 1. The fifth term also minus 1. This is the terms, the 5 terms of this sequence. Let's see number C. Question number C. The first term, let's substitute 1 here. Signum function, SGN represent what? Signum function. Signum function is a function that values here up. SGN x, which is equal to 1 for x greater than 0. X greater than 0 and 0 for x is equal to 0. For x is equal to 0 and minus 1 for x less than 0. For x less than 0. Now using this definition of signum function, let's compute this. If we substitute 1 here, 3 minus 1, 2. So 2 is greater than 1, so the first term will be 1 greater, comma. If you substitute 2 here, the second term, 2, 3 minus 1, 3 minus 2, 1. 1 is greater than 0, so 1 again. Let's substitute 0, 3 minus 3, 0. Signum function of 0, 0, comma. Let's substitute 4 here, 3 minus 4, minus 1 less than 0, so the value minus 1 here. Let's substitute 5, 3 minus 5, minus 2. minus 2 less than 0, so the fifth term will be minus 1. 1, 2, 3, 4, 5, 6, all are the fifth terms for this equation number C. Let's go to question number 2. List the first 5 terms of each of the sequence, which general terms are given below, where n is a positive integer. Okay, here this is the same with question number 1. Easily we can compute by direct substituting 1 for n 1, 2, 3 up to 5. Let's do n number A. Question number A. If you substitute here 1, minus 1 the power of 1 is minus 1, so minus 1 over 1. So the first term minus 3 comma. The second term, this is positive, so 3 the power of 1 over 2. 3 power 1 over 2. Next term, let's substitute 3. Minus 1 the power of 3 minus 1, so minus 3 the power of 1 over 3, comma. Let's substitute 4, minus 1 the power of 4 positive, so 3 the power of 1 over 4. The last term, comma. Let's substitute 5, minus 1 the power of 5 minus 1 minus 3 power in bracket 1 over 5. These all are the fifth term for question number A. Minus 3 the power of 1 over 2, minus 3 the power of 1 over 3 the power of 1 over 4, minus 3 the power of 1 over 5. These all are the fifth term, the first 5 terms. Let's do number B. Question number B is the first term. Let's substitute 1 here. E the power of minus 2, e power minus 2. This is the first term. Let's substitute 2 here, 2 times e the power of minus 4. 2 times minus 2 times 2 minus 4, comma. Let's substitute 3 is the power of minus 6, e power is minus 2 times 3 minus 6, comma here. Let's substitute 4 times e the power of minus 2 times 4 minus 8, comma here. Let's substitute 5 is the power of minus 2 times 5 minus 10. This is the solution for question number B. E the power of minus 2, twice of e the power of minus 4, 3 times e the power of minus 6, 4 times e the power of minus 8, 5 times e the power of minus 10. Let's see number C. Number C solution here. Let's substitute 1 the first term. Minus 2 the power of 1 is minus 2 plus 6 minus 2 4 over 1 minus 1 0 factorial is 0, so the first term 4 over 1 is 4. And second term, minus 2 the power of 4 plus 6 10 over 2 minus 1 factorial is 1, 10 over 1 10. Second term 10. The third term, minus 2 the power of 3 minus 8 plus 6 minus 2 over 3 minus 1 2 factorial is 2 minus 2 over 2 minus 1. The fourth term, minus 2 the power of 4 16 22 over 4 minus 1 3 factorial 6 22 over 6. After simplifying this, we get 11 over 3, comma. The last term 1 2 3 4 1 2 3 4 5 fifth term, minus 2 the power of 5 minus 32 plus 6 minus 26 over this 5 minus 1 4 factorial is 24. Let's simplify this. Get which is equal to pi to 12 minus 13 over 12. These all are 5 terms, the first 5 terms of this sequence. Let's do number D. Question number D. Question number D, let's compute it. If we substitute 1 the first term, minus 1 over 1 square 1, minus 1 minus 2 the first term, minus 2 comma the second term, this is positive 1 over 1 minus 1 over 2 square is 4, 1 over 4, 1 minus 1 over 4, 1 minus 1 over 4, 3 over 4, comma, let's substitute this is minus 1 over 1 over 3 square 9, minus 1 euro minus 10 over 9, comma, the fourth term this is positive 1 minus 1 over 4 square 16 minus 1 15 over 6, 15 over 9, I mean 15 over 4 square 16, 15 over 16, comma, next 1 2 3 4 5, this is minus 1 euro minus 1 over minus 1 over 5 square 25, minus 25 minus 1 minus 26 over 25. These all are the first 5 terms for this sequence. Let's compute question number E. Okay, if for the first term substitute 1 here, pi over 2, that is 90 degree, cos 90 degree 0, comma. When you substitute 2 cos pi is minus 1, comma. Next, let's substitute 3 pi over 2, that is 270 degrees, that is 0, comma. Let's substitute 4. When you substitute 4 pi over 2 pi, cos 2 pi is what? 1, comma. Let's substitute 5 pi over 2, 450, that is 0. 5 pi over 2, 5 times 90 degree, 450 degree, that is 0. 1 2 3 4 5. This is the first 5 terms for this sequence. Let's go to determine whether the sequence with the following general terms are arithmetic or not. To check whether this is arithmetic or not, let's list out some terms. So let's list out some terms here. Let's substitute 1 here. When we substitute 1 square 1 plus 5 times 1 5, 1 plus 5 6 plus 6 12 over 1 plus 2 3, 12 over 3 4, the first term 4, comma. The second term, let's substitute 2 here, 2 square 4 plus 10 14 plus 6 20 over 2 plus 2 4, 20 over 4 5, comma. Let's take once again. When you substitute 2 here, 2 square 4 plus 5 times 2 10 plus 6 over 2 plus 2, 4 plus 10, 14 plus 6 over 2 plus 2 4, 14 plus 6 20 over 4, which is equal to 5. That's correct. Now let's substitute 3 square. We have 9 plus 5 times 3, 15 plus 6 over 3 plus 2, 5, 9 plus 15, 24 plus 6 over 5, 24 plus 30, 30 over 5, 6. 30 over 5, which is equal to 6, so the third term will be 6. Okay, let me add one more. Let's compute the fourth term. 4 squared 16 plus 5 times 4, 20 plus 6 over 4 plus 2, 6. 16 plus 6, 22, 42. 42 over 6, 7. 7. So this is arithmetic sequence. Why? Because we have the common difference d, that is 1. 4, 5, 6, 7. 5 minus 4, 1. 6 minus 5 is 1. 7 minus 6 is 1. So this is an arithmetic sequence. Let's see equation number F. Whether it is arithmetic or not, let's substitute the sum terms here. The first term we substitute 1 here. 4 times 1, 4 plus 1, 5 square root of 5. Square root of 5 is equal to 5, comma, let's substitute 2 here. 4 times 2, 8 plus 1, 9 is equal to 9. That is 3. That is 3. Comma, let's substitute 3. 4 times 3, 12 plus 1, 13. Is equal to 13. Let me add one more. When you substitute 4 times 4, 16 plus 1, 17. Is equal to square root of 17. And so, but this is not an arithmetic sequence. Why? Because we don't have common difference d here. 3 minus this is not equal with this one. This minus this. So this is not an arithmetic sequence. Let's go to question number 4. Find the arithmetic mean between 1 and 9. And what we need to find here, an arithmetic mean. To compute an arithmetic mean, we take easily the average of these two numbers, arithmetic mean. Let's compute it here. M is equal to M, which is equal to 1 plus 9 divided by 2. That is 1 plus 9 over 2, which is equal to 1 plus 9 is 10. 10 over 2, which is equal to 5. This is the arithmetic mean in between these two numbers. Let's go to question number 5. Find the tens and nth terms of the geometric progression. Okay, let's compute it. Question number 5. The terms of geometric progression 5, 25, 125. Let's compute it. Common ratio R here first. Common ratio R is 25 over 5 is 5. R, which is equal to 5. So G10. To compute G10, G10 which is equal to G1 times G1 product is R the power of n minus 1, that is R power 10 minus 1, which is equal to G1 we have 5, 5 product is R we have 5, R also 5, 5 the power of bracket 10 minus 1, 9. This is equal to 5 the power of 5 power 10. This is equal to let's compute it. 5 the power of 10, 5 power 10, which is equals to this number 9,765,625. So this is 5 the power of 10 is 9,765,625. Now let's complete the nth terms. Nth term. find nth term, that is what we need to find, gn. Let's compute it. gn is equal to g1 times r to the power of n minus 1, that is 5. 5 is for common ratio r, so 5 to the power of n minus 1. This is the nth term. So again, let's substitute g1, which is g1 we have 5, that is equals to 5 times 5 to the power of 5 power n minus 1. Let's simplify this. This is equal to 5 times 5 to the power of n over 5 power n over 5. This is equal to, let's omit this 5 by 5, so we have 5 to the power of n. Let's put it in bracket like this. So this is equal to 5 to the power of n. 5 power n. This is the nth term formula. So let's stop it here. Today's topic. Let's stop it here. Thank you very much for your attention and for following me, and please try to subscribe and share it.